Maria Gaetana Agnesi was born in Milan, Italy in 1718. She was born into a wealthy and intellectually vibrant family. Her father, Pietro Agnesi, was a mathematics professor. He recognized Maria's extraordinary intellect early on. Maria was a child prodigy. She mastered languages like Latin, Greek, Hebrew, and French by age 11. This multilingual upbringing proved valuable for her scholarly pursuits. It allowed her to engage with works from across Europe. Agnesi's father provided her with private tutors. These tutors were leading intellectuals of the time. They nurtured her talents in mathematics and philosophy. This privileged education laid the foundation for her groundbreaking work. Agnesi thrived in her intellectually stimulating environment. She participated actively in her father's salons. These gatherings were frequented by renowned scholars and intellectuals. The salons provided a platform for Agnesi to showcase her growing knowledge. She engaged in debates and discussions on various subjects. Mathematics became her primary focus. She studied the works of prominent mathematicians. These mathematicians included Euclid, Newton, and Leibniz. Agnesi's intellect and dedication allowed her to quickly grasp complex mathematical concepts. She soon began developing her own ideas. At the young age of 20, Agnesi embarked on an ambitious project. She decided to write a comprehensive textbook on mathematics. This book, Analytical Institutions for the Use of Italian Youth, would become her most significant contribution to the field. Analytical Institutions was a groundbreaking work for its time. Published in 1748, it was a 2-volume masterpiece. The book covered a wide range of mathematical topics. It included algebra, geometry, calculus, and differential equations. Agnesi's writing was exceptional for its clarity and rigor. She presented complex mathematical concepts in a way that was accessible to students. The book was praised for its systematic approach and logical organization. It quickly gained recognition as an important mathematical text. Analytical Institutions was translated into several languages. It was adopted as a textbook in universities across Europe. This book solidified Agnesi's reputation as a brilliant mathematician. It also made her a pioneer in mathematics education. One particular mathematical concept discussed in Analytical Institutions brought Agnesi lasting fame, albeit with an unusual twist. This was the Witch of Agnesi curve. This curve, also known as the Versiera, had been studied by mathematicians before Agnesi. Agnesi provided a detailed analysis of this curve. She described its properties and provided methods for its construction. The curve's name, Witch of Agnesi, is actually a mistranslation. It stemmed from a misunderstanding of the Italian word versiera, which means turning curve. Somehow it became associated with the Italian word aversiera, meaning witch or she-devil. Despite the misnomer, the Witch of Agnesi curve became closely associated with Agnesi's name. Today, it serves as a reminder of her significant contributions to mathematics. The curve itself finds applications in various fields. These include physics, engineering, and statistics. Section 5.1. Recognition and renown, a professorship in Bologna. Agnesi's exceptional work did not go unnoticed. In 1750, she received an extraordinary honor. Pope Benedict XIV appointed her to the University of Bologna as a professor of mathematics. This appointment was highly unusual for the time. Women were rarely recognized for their intellectual capabilities, let alone offered prestigious academic positions. Agnesi's appointment was a testament to her exceptional intellect and groundbreaking contributions to mathematics. While she never formally accepted or taught at the university, the offer itself speaks volumes about her standing in the academic world. Section 6. A life of service, Agnesi's turn to charity. After her father's death in 1752, Agnesi's focus shifted dramatically. She dedicated the rest of her life to charitable work and religious devotion. Agnesi established a charitable institution in her home. This institution provided shelter and care for the poor and sick. Agnesi lived a life of piety and humility. She renounced her mathematical pursuits and devoted herself entirely to helping the less fortunate. Her selfless service earned her the admiration and respect of the Milanese community. Section 7. Legacy of a pioneering woman, Maria Gaetana. Agnesi left an indelible mark on the world. She was a brilliant mathematician, a gifted teacher, and a compassionate humanitarian. Her contributions to mathematics, particularly her book Analytical Institutions, significantly advanced the field and inspired generations of mathematicians. Although Agnesi chose to dedicate her later years to charitable work, her legacy as a pioneering woman in mathematics remains strong. She shattered stereotypes and proved that women were just as capable as men in the realm of intellectual pursuits. Section 8. Inspiring Generations: Agnesi's Impact on Women in Science. Agnesi's story serves as an inspiration for women in STEM fields. Her accomplishments in a male-dominated field challenged societal norms and paved the way for greater gender equality in academia. Her story reminds us that brilliance and talent know no gender boundaries. Agnesi's legacy continues to inspire young women to pursue their passions in mathematics, science, and beyond. Section 9. Conclusion: A legacy etched in mathematics and humanity. Maria Gaetana. Agnesi's life was a remarkable tapestry woven with intellectual brilliance, unwavering faith, and selfless service. She was a woman of many talents who excelled in mathematics, languages, and philanthropy. Agnesi's contributions to mathematics are undeniable. Her legacy extends far beyond the Witch of Agnesi curve. She stands as a beacon of inspiration for aspiring mathematicians and a testament to the power of intellect, dedication, and compassion.